Hi, I'm your math teacher, Sir Elias Ardana. You can follow me and subscribe in my YouTube channel, Sir El Senor, and message me in my Facebook account, El Senor of JCA. So, just a tip, when you watch your videos for your lesson, you can pause anytime, jot down notes, and when there is a question, pause, try to answer on your own, and then play to get the correct answer. The first lesson is all about sets, and sets are just groupings in mathematics. Okay, let's have some definitions. A set is a well-defined group or collection of objects. The keywords here are well-defined. You have to be specific in the definition of a set or a group. Here, I have the set of fingers of my left hand. You cannot be more specific than that. Okay, so here, this is a set, a group, the fingers of my left hand. Okay, and each member is called an element. So here on my left hand, this is the pinky, this one is an element, the thumb, the index, the middle, the ring finger. So each finger is an element. And we use this symbol, this is the Greek letter epsilon, and it is read as is an element of. So here, the pinky is an element of my left hand. The epsilon with the slash is read as is not an element of. So here it would be weird if you have a toe, because the toe is not an element of the fingers of your left hand. Okay, so let's have more examples. The set of counting numbers 1, 2, 3, 4, 5, 6, and so on. So those are infinite. You don't know when to stop or end. Okay, also another example is the friend list in your Facebook. So each person is an element of your set of friend list or set of friends in Facebook. Next one, how do we write sets? Usually we use capital letters to name sets and small letters for the elements. But sometimes capital letters usually are used for elements, but to avoid confusion, we use capital letters to name sets and small letters for the elements. Okay, remember that. Okay, when we list down the elements, the first method is called roster, because roster literally means a list. So it is a listing method. So here we list down the elements inside braces or curly brackets. For example, the set of numbers from 1 to 5 would be written as 1, 2, 3, 4, 5 inside curly or braces. And if there are many elements, we use the ellipsis. This is the three dots. In English or in sentences, it is read as etc., meaning there's more. But in math, when there are many elements, here the set of counting numbers, odd counting numbers, less than 1,000. So 1357, after 7 is 9, 11, and so on. So you know that there are numbers here in the middle. Okay, this one does not end. This one ends at 999 because it's only less than 1,000. This one is the set of all counting numbers. So you don't end. So after the ellipsis, there is no value there because it is infinite. The second way to write sets is using the set builder notation. Here you do not list the elements. we use a description. So this is read as variable such that, this vertical bar, and then the description. Okay, let's have an example. The variable x such that x is less than 6 and x is a counting number. So here we know that the variable x should be a counting number and less than 6. So those are 1, 2, 3, 4, and 5. How about this example? The variable x such that x is a fraction whose numerator is 1 and denominator is a counting number. So let's list down the possible elements. So here, the first one, the numerator is 1 and the denominator is a counting number. So the first counting number is 1. The next element is 1 and the denominator is the next counting number 2. And then we have 1 over 3. And we use the ellipsis because there's more. So this is an example of a set builder, and this one is the version of the roster method. Okay, so let's use the notation for is an element of. We know that that notation is the epsilon letter. Okay, if the set A has the elements 3, 17, and 2, we know that 3 is an element of A. Also 17 is an element of A. 2 is an element of A, but 5, we cannot see 5 there, is not an element of A. Another example, let's say A, this is a different set, is the variable x, such that x is a prime number, then 5, that's a prime number, is an element of A, but 6 is not an element of A. So that's how you use the roster. And then this one is the set builder notation. Okay, so Venn diagrams. Venn diagrams are visual representations of sets. And usually we use circles to represent sets. And then there's the label of the capital letter inside. And then we usually list down the elements inside the circle. Okay, so later on we're going to talk about Venn diagrams more when we do set operations. Let's talk about the empty set. When a set has no elements whatsoever, just like here, we use the curly brackets with nothing in them because we cannot list the elements. There's no elements. Okay, it's called an empty set or a null set. And here is the symbol of the null. Okay, when there are no elements in a set. How about a subset? A subset is a smaller set when the set A and the set B, if every element of A is an element of B. For example, here we have A is 1, 2, 3, and B has the elements 1, 2, 1. Okay, as you can see, set B is bigger and set A is smaller. So every element of A is an element of B. All the elements here in A are also found in B. Therefore, we can say A is a subset of B. Also, A is a proper subset because there are elements of B not in A. So this one is a proper subset. When will it be not a proper subset? When they are exactly the same. When they are the same, They are still subsets, but they are not proper because they are the same. A proper subset should be smaller than the bigger set. Remember that. Okay, so here are notations used for subset. This one is the subset. A is a subset of B. This one is a proper subset. A is a proper subset of B. And this one is for not a subset. A is not a subset of B. More definitions. Equal sets. Equal sets, two sets are said to be equal if they contain the same exact elements. Okay, so let me give you an example. So the set of fingers on your right hand is equal to the set of fingers on your left hand. They are equal because they contain the same exact elements. The pinky, ring, middle, index, thumb, exactly the same. So they are equal. When we have equivalent, two sets are said to be equivalent if they contain the same number of elements. So let me give you another example of equivalent. Okay, so this one, your right hand has 5 elements, and the one listed there, 1, 2, 3, 4, 5, also have 5 elements. They have the same number of elements. Therefore, they are equivalent sets. The counting numbers from 1 to 5 and the fingers in your right hand are equivalent sets because they contain the same number of elements. For equal, it has to be exactly the same elements. For equivalent, just the same number of elements. Okay, cardinality is what you call the number of elements in a set. So usually it's denoted by this symbol n in parentheses or 2 vertical bars. So here the cardinality is 5. In this example, the cardinality is also 5. Let's have examples. Here A has the elements A, B, C, D, and B, set B, has the elements B, B, C, A. As you can see, A and B are equal sets. Let's have M, the set of natural numbers from 1 to 20. So those are 20 elements. And P, the set of counting numbers from 41 to 60. Those are also 20 elements. Therefore, M and P are equivalent sets. And here is an example of cardinality. This is how you write cardinality. The number of elements of A equals 4, or you can use vertical bars. Also P, cardinality of P is 20, so the number of elements of P is 20. And the next part of our lesson is set operations.